A near-Earth object is any small solar system body whose orbit brings it into proximity with Earth. They are generally defined as an asteroid or comet that approaches our planet less than 1.3 times the distance from Earth to the Sun. If a near-Earth object's orbit crosses the Earth's, and the object is larger than 140 meters across, it is considered a potentially hazardous object. Most near-Earth objects pose no peril at all. It's the small percentage of potentially hazardous asteroids that draws extra scrutiny. There are over 25,000 known near-Earth asteroids, over 100 short-period near-Earth comets, and a number of solar-orbiting meteoroids large enough to be tracked in space before striking the Earth. It is now widely accepted that collisions in the past have had a significant role in shaping the geological and biological history of the Earth. Asteroids are rocky fragments left over from the formation of the Solar System about 4.6 billion years ago. Most asteroids orbit the Sun in a belt between Mars and Jupiter. Occasionally, asteroids' orbital paths are influenced by the gravitational tug of planets, which cause their paths to alter. Comets are relatively small, fragile, irregularly shaped bodies, and like asteroids, they are left over from the Solar System formation process. Comets, however, are icy dirt balls that form in the outer Solar System. The icy surface is embedded with dust, grit, and particles from space. Bennu has the auspicious status of being one of the most hazardous objects in the Solar System. Bennu is a near-Earth object with the potential of colliding with the Earth in the distant future. The current prediction, out to a few centuries, estimates the likelihood of a collision to be very low. OSIRIS-REx is already contributing to our understanding of what influences Bennu's movement through space. Near-Earth objects may provide needed raw materials for future interplanetary exploration. Some should also be fairly easy to land on for future exploration. Potentially hazardous asteroids are about 150 meters or larger, roughly twice as big as the Statue of Liberty is tall. Knowing the size, shape, mass, composition and structure of these objects helps determine the best way to divert one. While traveling through space, asteroids sometimes collide with each other and break up into smaller fragments. These breakups result in numerous small particles and fragments, called meteoroids. Most meteoroids are small and rocky. When one approaches Earth, it burns up as it goes through Earth's atmosphere. Fireballs are larger meteoroids, roughly ranging in size anywhere from a basketball to a Volkswagen. They also make very impressive sky displays as they break into fragments and burn up in their passage through Earth's atmosphere. Some meteoroids survive passage through Earth's atmosphere and hit the ground. These are called meteorites. There are two schemes for the scientific classification of impact hazards from near-Earth objects. The simple Torino scale, which rates the risks of impacts in the next 100 years according to impact energy and impact probability, using integer numbers between 0 and the more complex Palermo technical impact hazard scale, which ascribes ratings that can be any positive or negative real number. These ratings depend on the background impact frequency, impact probability, and time until possible impact. The main problem with estimating the number of NEOs is that the probability of detecting one is influenced by a number of aspects of the near-Earth object, starting naturally with its size, but also including the characteristics of its orbit. Collision avoidance strategies can also be seen as either direct or indirect and in how rapidly they transfer energy to the object. The direct methods, such as nuclear explosives or kinetic impactors, rapidly intercept the bolide's path. Indirect methods, such as gravity tractors, attaching rockets or mass drivers, are much slower. They require traveling to the object, changing course up to 180 degrees for space rendezvous, and then taking much more time to change the asteroid's path, just enough, so it will miss Earth. Initiating a nuclear explosive device above, on, or slightly beneath the surface of a threatening celestial body is a potential deflection option, with the optimal detonation height dependent upon the composition and size of the object. It does not require the entire near-Earth object to be vaporized to mitigate an impact threat. Scientists have determined the likely origin of the dinosaur-killing asteroid that brought about their extinction and killed 3/4 of all life here on Earth. This asteroid is officially known as the Chicxulub impactor, and it struck the Earth 66 million years ago. The 6-mile-wide Chicxulub impactor originated in the asteroid belt space in between Mars and Jupiter. In this instance, the asteroid was pulled from its location way out in space to Earth, where it eventually crashed and created a 90-mile crater. What is a dinosaur's least favorite reindeer? Comet.